For example circuit number 7, we're looking at wiring a different type of sensor into your Arduino kit, in this case a temperature sensor. This temperature sensor is going to take a fixed voltage across itself and then output a variable voltage depending on the temperature of the sensor. So the schematic for this sensor is extremely simple. We simply connect 5 volts to power, ground to ground, and we hook this middle pin P1 into analog port 0. So, extremely simple circuit. We just power the element itself and then hook its sensor pin into analog pin 0, and we're good to go. The circuit itself is just little this is our temperature sensor, and it's hooked into our Arduino. So the sketch for this is going to look like this. So the sketch starts by defining the temperature input pin, 0, and then in the setup phase it starts up with serial begin. So we know that we're going to have a serial output to the serial window, so let's open up the serial window and stick it behind there so that we'll be able to read its output. Now for the main body of the program, we're going to define 3 variables, except this time we're going to use floating point instead of integers, because we're going to want to be able to read fragments or fractions of voltage and fractions of degrees Fahrenheit and degrees Celsius in order to get a more accurate reading. If we were to just use int for these values, we'd be very, very restricted in what we could actually read. So, voltage is get voltage of temperature pin, and get voltage is a function here, and we're passing a temperature pin. So let's go find get voltage. So float get voltage of int pin. So this function is going to return a floating point value after receiving an integer value for pin. And the function is simply a return statement which says end this function and send back the value I've been given here. And you want it to return analog read of pin times 0.0048882814, and this is a correction factor which changes from the 0 to 1023 value that analog read will give you to a 0.0 to 5.0 value, which is the actual voltage being read. So this function very, very simply calls the function, gives it a number for the pin, and the function immediately says, okay, send back the number that's at that pin multiplied by a correction factor to get it from 0 to 5. So we've got our voltage, and we pass back up to the main function, store that in voltage. And degrees C is equal to the voltage minus 0.5 times 100. And this particular formula is specific to the sensor. So for the sensor I'm using for this starter kit, this is the formula you use. The degrees C, the voltage at any degree C is based on this formula. So if you buy your own temperature sensor, it should have some sort of correlation formula that says this is how you convert your output into a temperature that you understand. And next is degrees F, and we're simply using the Fahrenheit to Celsius conversion factor here. So degrees Celsius times 9/5 plus 32. And that will convert our degrees Celsius into degrees Fahrenheit. And now we're going to output all these to the serial monitor. So printing voltage colon space, and then the voltage, printing space degrees C colon space, and then the degrees Celsius, then space degrees Fahrenheit space, and then serial print terminate with new line, the degrees Fahrenheit. So it should print the voltage, a value, degrees C, a value, degrees F, a value. And then we've got a delay 1000 here, so it'll wait 1 second before popping the new value up on the screen. And that'll basically stop the command line from being just an endless illegible scroll of values. So if we run this program, it's going to start popping up, and it's saying the room I'm in is about 64, 65 degrees. Yeah, about 64, 65 degrees. And if we switch over to webcam again, it's just running. That thing's just going to run. It's not going to appear to do much of anything. Now, in order to make sure that it's actually working, that the temperature sensor is actually reading anything, I'm going to go and I'm going to grab that with my warm, probably around 98 fingers. So if we go back here, we should see the temperature as, in fact, yes, the current readings are around 80 F. So it is, in fact, reading that my fingers are, while they're holding this transferring heat to the temperature sensor, they are much warmer than the air of the room itself.